Welcome everyone. So myself Raguraman, working as assistant professor in Department of CSE, Madanapalle Institute of Technology and Science, deemed to be university. So today I am going to take a topic which is based on content-based image retrieval, which is one of the concept of image processing techniques. Okay. So before going for this particular topic, you will see what is meant by images, the types of images, then how it can be get processed and all those things. So first, what is meant by image? So image is a collection or group of pixels which is represented for each and every images. So this images cannot be directly evaluated. So what we have to do for this images? So this images has to be first converted into some other type or mode of transformation. From there, we have to convert this mode of transformation into a machine understandable form, which is called as zeros and ones. Then only it will be get evaluated because images are having a huge size of content. So it occupies a huge quantity of storage in our hard disk. So directly if you are taking or if you are started to process our images, it is not possible at all to compute the exact output result, even it may take in terms of hours or days also. So in this regard, how I can able to go for evaluating these images, how we can able to compute these images. So these are all the topics. So these are all the topics that we are going to cover today. So introduction to content-based image retrieval, history and how it evolves, and applications in real-time applications, architecture or the steps of content-based retrieval, and similarity measures. That is, once if we started to evaluate the informations, that is image information, the next step that what we have to do is we have to evaluate the accuracy of those images. So how much percentage this images has been mapped with our database images. So first we'll start with what is meant by a content based image retrieval. So it is a vision technique, a computer vision technique which searches for the relevant images from a huge quantity of databases. So huge quantity of databases which consist of the similar type of informations. For example, I am having a group photo. So I am from the group photo, I need to identify or I need to detect one particular person with some features. So those features I need to extract. Then how it is possible? So I am having in terms of hundreds or thousands of images. From those images, I need to identify or I need to segregate that particular person alone. Then how I can able to segregate that particular information? So that one we called it as a content based image retrieval. So a multimedia information which is nothing but our images is not going to be extracted only from a still photographic images. Either it may be from any type of multimedia images which consist of animations, videos or motion pictures. So how this images has to be? So images has to be stored efficiently because we say that each and every images will consist of in terms of megabytes of size. So by now when we are taking a simple photograph through our mobile phone itself, based on the pixel clarity of our mobile phone, the size may get varied from few megabytes to a maximum megabytes. So few megabytes deals with 2 MB, even maximum up to 12 MB also. The same information if I am taking with a DSLR camera, then surely for each and every image the size will be more than in terms of 30 MB. So 30 megabytes of images, if I am storing 100 images, then the storage will become too slow. So it will be occupied more amount of space. Second thing, it has to be indexed accurately. So indexed accurately in the sense each and every information has to be get extracted in a within a minimum amount of time. So easily retrieved too. So next one. So what are the different types of image retrievals we can able to go for? So one thing we can go for a text based or keyword based image retrieval. So what is this text based or image based retrieval? For example, I am having some set of cars over here. So in this cars, I am giving a text or a query as I am searching from n number of images which may be consisting of cars, lorries, trucks, two-wheelers, all those things. Now my keyword or the text is going to be cars. Now I am not going to tell any features, the exact features, how the appearance of the car should be. So car by default it will be having an entire closed content as well as it will be having a four wheelers. So whenever it is having a four wheeler by default it will be identified as a for cars. Whenever I am searching for the keyword as a bikes, two-wheelers will be always defaultly will be considered as a bikes. It doesn't have any coverage, the top cover or anything else. So everything is common as a two-wheelers or a bikes. So it is a general representation. So this type of representations we call it as a text-based image retrieval. So all these things are the fundamental types of retrievals whenever we are going for searching in a Google search. For example, I am searching for a keyword, images of a car, images of a birds. So I am representing a specific type of cars. Okay. So there I am trying to give the general notations of car, birds, animals like that. So it is called as a text-based image retrieval. Current vision, the deep learning, this type of techniques we are going or following a semantic based image retrieval by clearly mentioning its features along. So here the second one is the deep learning type of things, a semantic based image retrieval techniques. So here we are having more number of cars images. In this, for each and every images I will be having a specular type of contents. For example, the first one we call it as a hatchback, which is having a slide closed in the background. Next one is a sedan car, which is having a backside dicky, which will be extended apart from the seating space. Next one is a car or it may be a van. So which consists of a closed element or component which having more space. So next one if you go with, it will be considered as a convertible car. That is the top cover may be opened or closed whenever it is needed. So next one is SUV. The size will be get extended, the specifications will be extended like that. So next one is a pickup truck. So the back side of the entire truck has been opened. So where I can able to take some spares of a car or spare something, I can able to tow some other cars along with this, which is having a heavy duty type of engines. So I am searching for, so the best example for semantic based image retrieval goes with, we can able to go for booking like a Ola cabs or anything other cabs. Okay, so there I will be expecting that I need to get a car for two members. For two members, a simple car is enough. Either it may be a sedan car or it may be a Wagoner or hatchback. Okay, so whenever some four members or five members or six members are going, this hatchback or sedan is not sufficient. Then I need to go for a van type of car. Okay, so the type of car I need to clearly mention how many persons, how many seats are available, and for which purpose that particular car is. So I need to give entire features about the car. Then it is considered as a semantic based image retrieval. So going with the next one, history of content based image retrieval. Initially it is called as a Genesis based era. So it starts in the early midst of 1990s because this is the first time where this particular image retrieval process came into a software tool, and it is evaluated or introduced by the Japanese researcher called as Toshikazu Kato, which is entirely focusing for extracting the color and shape features alone. They are not in depth, they are not providing any informations regarding that. They are only entirely concentrating on extracting the colors. So what type of colors? For example, I am going with a rose. Rose is not only going to be a red color, it may be a pink, it may be a white, yellow, whatever it may be. So the type of color I need to extract along with the shape. Okay, so shape deals with the previous one what I said. Okay, so how it has to be, the petal size or the type of cars. Okay, so in 1992 the first software has been, or the method technology has been introduced in the year of 1992 by the Japanese researcher Toshikazu Kato. So next intermediate level goes with the feature engineering era. So this is the first place where more amount of features has been detected from different perspectives. It's not only based on the color and shape features, also it goes with the position and regional also. So some of the algorithms deals with is shift and surf. So these two algorithms are most probably used algorithm in the year of 1990s and 2000s. So where they exactly focusing to extract more amount of features other than the colors and shape. So currently, whatever currently we are using, we call it as a deep learning era, that is to present. So it uses the Euclidean distance as well as the CNN, not only CNN, even it goes with a YOLO, K nearest neighbor, KNN, all these things we goes with. So real-time application. So it is not limited up to this. It extends beyond this limit because image processing goes with image processing and computer vision nowadays. Wherever we go, all these things will be get extended beyond our eyes, whatever we are looking. Okay, so the first application goes with healthcare and medicine. So first one goes with a diagnostic support. So where if I'm having a diabetic patient, so in which level that diabetic patient are currently in. Now, which type of treatment and food recommendations I need to provide. So all these things has to be taken care by the diagnostic support peoples. Next one is dermatology, the skin care supporters. Okay, so skin disease also get varied from person to person. Okay, even if it goes with a cancer, skin cancer for example. So skin cancer may vary from beginning level to the advanced level. So I need to identify in which level it goes on. And next one is a tissue analysis. So tissue analysis is not only deals with the skin, it also deals with the blood platelets also. So RBCs, WBCs, so how much virus the infection has been affected the blood, for example, blood cancer. So this type of things we can able to analyze easily through healthcare and medicine by using your content-based image retrieval. So second application is forensic and law enforcement. So forensics, we go with a biometric identification. So some places that guilty persons may touch some properties or some things. So I can able to identify, take the biometric or fingerprint, and from the database I can started to trace out which person this particular biometric represents. Next one is digital forensics. So laboratories, okay, so all these things. Next one is evidence matching. So this one goes with the pattern matching phases. So evidence matching goes with the matching phases. It's not going to be image recognition phases. So next one is e-commerce and retail. So earlier days, what we will do is we will go to a shop. We started to see the products by our eyes, and we'll started to test, and then we'll start to purchase. But now everything goes with e-commerce. So online purchase, Flipkart, Amazon, everything goes on. So now how this particular content based image retrieval helps. So first one is a visual search. So visually how the product is. Okay, so what is the specifications? Logo, the company logo. The final one is brand protection. For example, Samsung, even if in real time markets, we can able to see more number of fake products, China products in real time worlds, which equivalent visualization, logo, everything will be similar with your iPhone or Samsung or Nokia, whatever it may be. So here this type of brand protection is needed whenever I started to search for the similar type of logos are available somewhere or else. So next one is satellite and remote sensing. So satellite images whenever a disaster or a cyclone, if anything goes on, a slight changes in the sea surface. So this type of things we can able to evaluate by using a radar or a sensor. So geographical mapping and disaster response through radars and sensors. So next one is art, museums and cultural heritage. So one place near to Madurai, they will be calling it as most famous, okay, for identifying the historical contents. Okay, QAD. In Tamil Nadu, they will be calling a place called as QAD. So it is mostly famous for extracting the historical ornaments or historical properties which the olden era peoples have been used, including gold, statue, everything they started to retrieve. So this one is a separate set of art. Okay, so cultural heritage. So authentication and archive organization. So which place this particular property belongs to, in which era it belongs to, which type of peoples they used. So all these things can be evaluated by using your content based image retrieval. So it's a simple steps or architecture of your content based image retrieval. It works both side, that is both offline as well as online. So we'll see one by one. So all our databases will be evaluated or stored in our local devices only. So database is available in vector database. So it is a offline, that is in our system, local system, all our database images. So with which images we are going to trace out, all the database will be available in our storage, that is offline database. Now I'm having a number of image database, which the first step of your image processing is a pre-processing. So pre-processing deals with resizing, filtering, rotation of the actually existing images. Because whenever I'm identifying a particular image, I am going to identify it from a huge, that is a group photo or a huge quantity of informations. So now what I need to do is, I need to crop that particular image which I need from a group photo. Okay, so this pre-processing will started to identify resizing, filtering, scaling, rotation, all these things will happen over here in the pre-processing steps. And next one is feature extraction. So feature extraction is going to be done. So whatever we have seen by now, surf, sift, all these algorithms will work on feature extraction mechanisms. So I'll be identifying based on colors, shape, size, text type. So everything will be get evaluated. So some of the example I given here is low level goes with the color histograms and edges. So color histograms is one of the easiest way of converting your images into another mode where it will be easy for evaluation process. So how we are evaluating your normal data sets. If I am giving an image, directly if I am computing, it will take more amount of time because the color range is starting from 0 to 255 colors. But the same information if I am converting into zeros and ones, that is a background, black and white images, then it is going to consist of zeros and ones, that is black and white. Zeros goes with black and one goes with white. So it is easy for me to evaluate with zeros and ones which your machines can able to understand. The same thing will be compatible over here for image processing. Instead of converting into zeros and ones, I am converting into histograms like a graphical format. Next one, feature vectors. So whatever the feature, for example, in this particular photo, I am trying to evaluate one particular image. Now what it is going to identify is, from the face feature, it will started to identify the intensity values, that is the color, distance between the nose to eyes, nose to forehead, nose to mouth, nose to chin. So all these features, so feature vectors is nothing but for each the measurement or the distance between each and every point. Okay, so this is what we call it as a feature vectors. So parallelly, in online process, through the query retrieval, I am going to extract the informations. So what are the features I am going to have? I am collecting the information about a car, for example. So car is the query image I given. So it started to give what are all the different types of cars in that website I am having. So now query feature extraction. So when the feature is going to be done as a car, so car will have a four wheels, the entire body will be get covered. So then it is called as a car. Okay, so query feature extraction it goes on. So next one is similarity matching. So whatever the feature extracted from the local database will be get extracted or evaluated whatever the query process given. So these two things will be get combined or given as an input for similarity matching. So what this similarity matching will do? So it will start to identify what type of cars you ask for, whether you ask for a sedan type or SUV type or truck. So what type of cars you identified. Okay, so by using the Euclidean distance quotient transformation. So the final one is from the database whichever we evaluated, it is going to be image retrieval and ranking. So here the final step what I need to do is I need to give the exact value or the percentage of similarity indexing or matching. So then only I can able to know or came to know that how much informations or features this offline database and online database has been get mapped. So it may be mapped more than 100 percentage or it may be 50 percentage. Okay, so final one is I need to give the percentage of similarity index, and final one is any relevance about feedback. So most probably this phase will never happen. Okay, so because in feature mapping, whatever the images we are going to search, it will be already available in online or offline mode. So with those images only we are going to evaluate. If those images are not there, the final image is going to be not available in that particular photo. This is the default. So steps. So the first step is feature extraction. So which is nothing but what we come in the architecture diagram. So the system will translate the visual content of an image into a numerical format, that is zeros and ones. So we already seen that images cannot be directly evaluated by any machine or deep learning algorithms. Before going for that, we have to convert those images into a proper image formats. Then only it will be get evaluated. So this type of feature extraction, we call it as a feature vectors. That is mapping of each and every features like nose, eyes, ears, everything. Okay, so which includes the color, texture and shapes. So next one is indexing. So indexing deals with, so I will explain with your diagram also. So indexing deals with, so feature vectors and your vector database. So the last phase. So this two we call it as a indexing, that is similarity matching. Okay. So in similarity matching, it goes with indexing. So your database information will be get connected with your online database, and these two informations will be get all evaluated. And the last one is similarity matching by using your Euclidean distance or similarity cosine transformation. So what is meant by Euclidean distance? Euclidean distance represents, for example, I will be considering image I1 and image I2. So these two images I am mapping the straight line distance between these two vectors. That is, I am taking one image, I am giving my photograph, and in another image I am giving my Aadhaar, uh, PAN card, ration card, all these things. Now these two images will be having a single type of similarity informations. That is, one photo will be get mapped or matched with another single photo. It's not a group photo. Okay, so these two photos has to be matched. So now what happens is, I know that in two photos my face is going to be get reflected. So it's a straight line distance between two vectors. The maximum similarity I can able to identify. Next one is cosine similarity. So this type goes with identifying my photo in a group photo. So in group photo, each and every person's face or images will be get matched. So in cosine similarity, I am having image I1, image I2 is a group photo. There I am going to map each and every similarities between the two vectors, angle between the two vectors, because the image in I1 is one photo. In image I2, I will be standing in the first row or type right corner or left right corner or bottom corner. Okay, so this type of evaluating change of angles. So the best thing is cosine similarity matching I need to map. So how this mathematical formula for similarity measure? So first one is Euclidean distance. Let us consider the distance between x and y, that is image 1 and image 2 is considered as the square of the distance between image 1 and image 2 or pixel 1 and pixel 2 in both the images. So square root and square will be get cancelled, and finally what we will be getting is only the difference between the two pixel values. So next one is Manhattan distance. It is also one of the type of image representation. So it is represented as the distance or the difference between sum of difference between image 1 and image 2. It's not going to be a square, it's sum of. So each and every pixel value will be get mapped with images. So next one is Chebysky distance. So the maximum value between two images will be get evaluated, and those two images the difference will be evaluated. So among the difference between each and every pixel value, the maximum value will be considered here. But here in the above, only the sum value will be considered. But here, after evaluating the difference, the maximum value between these two images, pixel values will be considered. So next one is correlation and angle based. That is the cosine similarity. That is one photo with multiple photo comparison. So cosine similarity deals with x, the multiplication, because cross vector. I need to check one image with the multiple images. So cross vector. So the image value between two images x cross product with y divided by the sum of. So here the vector quantity will be mentioned. So double cross or the slash. This bar symbol represent a positive value. So even if I am getting a negative value, whenever I am going with the difference, if I am getting a negative value, those negative value will be converted into positive values. So cosine similarity index compares each and every pixels with entire photo with the next image. So next one is statistical and distribution based metrics. So here histogram intersection, and chi-square statistics. So from the name of chi-square, we considered as the square of original image as well as the expected image. So O is the original image and E is the expected image, expected output divided by the expected output only. So we will see one simple example. Okay, so how this CBIR will be deployed. So with this one type of algorithm, we call it as ORB, that is oriented fast and rotated brief. So this algorithm, what it will do is it will started to identify each and every pixels. So oriented fast, that is tracing or tracking of information will be fast, and also once if the information has been grasped, automatically your information will be started to rotate, scale, flipped, all these things will be done by your algorithm by automatically. Okay, so I'll show one simple example over here. So OR. Okay, so this one, the first thing is loading of libraries. So I'll try to maximize where we can able to see somewhat extent. So first one, we have to load our prerequisite directories. Okay, so prerequisite directories we need is CV2. Okay, so computer vision version 2. So why we need computer version 2 is we are going to deal with in image type of information. So we need this type of image import. So next one is your normal Google Colab, Matplotlib for converting your images into an histogram and binary formats. And the final one is Colab patches. So what this Colab patches will do is all your technical keywords which we are using in image processing, that is keywords in your algorithm, all these keywords will be get mapped over here. Okay, so after loading your important library files, the second step is loading your actual input, that is input image 1, the image which I need to search for, the input image. Okay, so here upload query is equal to files.upload. So what here it will happen is here it will start to request you for you upload the file or the image what you needed. Okay, so here I'll run parallelly. So it will started to run your query. Okay, so because I need to connect with the RAM with the server. Okay, all right, so no issue. Okay, so maybe internet connectivity issue. So once if the image, the actual image whichever we have to upload, that image has to be uploaded here. After that I need to upload image 2, that is image 2 is nothing but multiple files. Okay, so image 1 is the image which or where I need to search for, and in the second uploading image is going to be from the database. So n number of images or n number of photographs from different background, different shapes, color, textures, intensity levels, background, everything. So you can able to upload n number of informations or n number of files over in the second query. So I uploaded some of the 4 files. So first file I uploaded my earlier photograph which is taken during my BTech. Second one is I have taken my college institutional ID card, PAN card and another photo. Okay, so 4 photographs I have taken. Now in these 4 photos I need to map from the image 1 which among these 4 photographs is having the maximum similarity index value. Okay, so here I need to implement my orb implementer. So create, so first I need to create the orb, that is the patches whichever I needed. So in the include fields I have included my patches, so Colab patches. So in this patches this orb will be started to work out. So create orb. So after creating I am going to click, one is the queue, another one is the destination queue. Okay, so first one is the original image and second was the destination image. So in which image the maximum similarity index has been mapped. So orb dot detect and compute is a keyword which I am going for. I am going to identify and compute evaluation I am going to do. So through the query. So query is nothing but I am going to detect and compute is the query. Okay. So next one, I am going to compare the first image, original image with the comparative images. Okay. So first one, so BF matcher, binary form matcher, CV2 dot normalized Hamming code. So Hamming code I am using here, which say histogram equalization, cross check is equal to 2. So here what it will do is, it will take my original image I1 and it will start to compare each and every second, third, fourth, fifth, n number of images. Either it may be a group photo or an individual photo, it will started to trace up. Okay. So best match is equal to none. So still now no best match has been identified. So once if it is identified, the final stop destination is destination DB. So this one here I need to display my best fit. Okay. So best match name is none still now. Next one is best score is equal to -1. So what it will do is, still now I have not started. So 0, 1. 0 which is nothing but not mapped or not identified. 1 in the sense the best match has been found. So still now the best score is -1. So positive values it has to come. Okay. So now I need to search for each and every images, because DB name where I uploaded my actual image, input image, and DB images is the images where I uploaded my resultant images. 5 images I uploaded. So those images will be computed. So CV2 dot read each and every image I need to read, but I already said the actual original images is RGB images. This color images will never be computed directly, since the computational time may get varied, they extended. So what I am doing is I am computing all these informations into grayscale image, that is black and white images. Okay. So next one, I am going to identify the key points over here. So kp.db and destination. So my original image, comma, destination image is equal to I detect and computed. So once if this entire process is completed, the final step is I need to display that output. Now, if destination.db is none, then you have to continue. Okay, because destination database is completed, that is a tracing of all the input images, okay, has been complete. All the 5 files has been traced out. Now I am going for the next process. Okay, so now I am going for the next process, match. So match your destination with your destination database, and the final one is I need to print the score. So whenever I am running this command, you can able to see the below statements. Okay, I'll start it to enlarge. So you can able to see the maximum similarity index. So whichever images I have uploaded, the first image is having only 86% of similarity index. My college ID card with my uploaded image is having 97%, and with my PAN card it is having 99%, but with my actual image which is taken during my BTech, it is having 1112% of similarity index. So the best index where I am getting is with my BTech photographs. So whenever I am computing this, you can able to see the maximum photograph will be this two. Okay. So I will show what are all the photographs I have taken or I have uploaded earlier also. Okay. So these are all the contents I have uploaded. So first photo I have uploaded this, and second one is my PAN card, Aadhaar card, and college ID card, and this is my photo which is taken in the BTech, and this is my final photo which I uploaded as the image one. So image 2, 3, 4, all these things are second query which I uploaded 1, 2, 3, 4, 5 images. Okay. So all these things uploaded and it has been computed. So it's a simple matching with one-to-one matching. So one-to-many we have to go for using a cosine transformation. Okay. So thank you very much.